This question is a lot simpler and will go quicker than it may initially seem. So we just need to know a few properties about matrices. So the question says, 4 matrices are given below. We have W, X, Y, and Z. And the matrix is just an arrangement of numbers. We'll talk about how in just a second. And then it says, which of the following matrix products is undefined? So first of all, products means we're going to multiply. And matrix multiplication has a whole process to it, but in order to even do the multiplication of a matrix, we just need to know 2 things. First of all, the way in which matrices are arranged is their dimensions are rows by columns. So if we look at W, how many rows does it have? 2. How many columns does it have? 2. So I would say that the dimensions of matrix W are 2 by 2. X is arranged in the same way, so it is also a 2 by 2. And then Y is a little bit different. Let's check out its dimensions. It has 2 rows still, but 1, 2, 3 columns. And again, it goes rows by columns. So it's 2 rows by 3 columns. All right, Z changes yet again. This time it has 1, 2, 3 rows. So 3 rows by 1, 2 columns. Okay, so those are the dimensions of those 4 matrices. And then the only other thing we need to know is that in order to multiply matrices, the columns of the first matrix, so the columns of the matrix that's listed first, must match the rows of the second matrix. So columns of first matrix must equal the rows of the second matrix. Okay, as long as that's true, we can do the multiplication, we can find a product, but we're not even asked to find that product. We just want to know which ones can we do. So WX is our first product listed, and you could just scan through these, but we'll go in order. WX, the columns of W, our first matrix, does it match the rows of our second matrix? Columns of W is 2, rows of X is 2, they match. This one, you can find its product. Let's do WY. The columns of W, does it match the rows of Y? 2 and 2, yes, so that works. Okay, let's check out Y times Z. So Y is listed first. So we want the columns of Y. Does it match the rows of Z? This is a 3, that's a 3. It matches. We can do that product. Okay, D. X is listed first, so the columns of X is 2. Z is listed second, and the rows of Z is 3. So right there in X, the columns of X is not equal to the rows in Z. So this product can't happen. So that looks like our answer. We've come this far, let's check out E and make sure E can work, and then we'll feel confident about D. So the columns of X, does it match the rows of W? And here's the rows of W. So 2 and 2, they match, we're good to go. So this works, meaning we can now confidently say the product that doesn't work, the 2 matrices that cannot be multiplied because the columns of the first matrix doesn't match the rows of the second matrix, is X times Z.